to the Digital Agri-Food Summit Innovation Showcases. I'm Olivia Carver and I'll be your host this afternoon, and I'm also the host of Food Agility CRC's Ag Tech Finder podcast. And I may have met some of you previously in my prior role as a rural reporter based in the Riverina. These showcases are concise presentations of the latest agricultural research and innovation. They're the latest in real-life case studies, and we have panel discussions responding to the theme, Paddock to Profit. We're going to begin the showcase this afternoon with a panel discussion to explore the Cool Soil Initiative, a project involving both Food Agility and Sturt University, which supports farmers in exploring their practices to improve the health of their soil, increase yields, and reduce on-farm greenhouse gas emissions. Please welcome Project Lead Dr Cassandra Schefe and Sandy Gain, Climate and Sustainable Sourcing Lead for CSI partner Mars Petcare. We'll begin this panel discussion with a short video.
Australian grain farmers are feeling the effects of climate change, with drought conditions impacting their crops. So in 2017, Mars Petcare took action to quantify and reduce greenhouse gas emissions by developing the Cool Soil Initiative, a true paddock to product partnership that will help Aussie wheat farmers adopt innovative soil health practices to increase yield and improve crop resilience to climate change. Using the Cool Farm tool, a greenhouse gas, water and biodiversity calculator, project leads are able to monitor soil carbon sequestration and its impact on the emission values. With our new partners on board, the Cool Soil Initiative will grow to a $2 million commitment, with over 200 farmers over the next 3 years. Already our farmers involved cover 50% of New South Wales, with 100% retention of participating farmers and more than 30,000 acres of innovation paddocks. If the Cool Soil Initiative can restore a 0.1% increase in soil carbon across 1.7 million acres, the impact would be the equivalent of removing more than 1 million cars from the road. We know we can only solve big challenges like the impact of climate change through industry-wide collaboration. The Cool Soil tool is a scalable framework for the food industry to get started on making a better world today.
Well, welcome Sandy and Cass to the panel discussion. Thank you for being here and thank you for that video. It gives us a good overview of the program. Sandy, are we able to start with you? Are you able to tell us why Mars Petcare wanted to conceive a program like the Cool Soil Initiative?
Yes, absolutely. I think for Mars, it all started with our Sustainable Lineage Generation Plan, which is how we call our sustainability program, that we launched in 2017. And I think we understood back then that we had a responsibility, but also an opportunity to reduce our impact on people and the planet. And the reality is that most of our impact on the planet comes from our extended supply chain. So just to give you an idea, 75% of our greenhouse gas emissions come from agricultural practices and land use change, directly associated with growing ingredients that we use in our products. So this is where it started. And we have a manufacturing site in Wodonga. We have another one in Bathurst. So starting with, supporting wheat growers in that region between our two manufacturing sites, I think was a natural place for us to start.
And Cass, you've been the project lead of the program since its conception. A lot of people in this room and online may understand this already, but for anyone who doesn't, are you able to explain the connection between soil management practices and greenhouse gas emissions?
Yeah, sure. So as most of you are probably aware, the key drivers behind a lot of on-farm emissions are actually from nitrogen fertiliser and also from soil processes, including the breakdown of organic matter. So by having that really strong focus on our soils and how we can maintain and support condition, that then improves efficiency in nutrient cycling, greater uptake and availability of nitrogen and other nutrients in the soil, and then use of fertilisers. So by basically and effectively starting from the ground up, we've been able to demonstrate not just the role of that, but really practical ways on how we can then inform reductions in emissions on farm.
So how does the Cool Soil Initiative, how does that support farmers in making sustainable farming practices decisions?
So we go right back to the start in terms of peer learning. So we don't just go out there and say, look, this is what you need to do. We've actually set up really strong hubs of farmers all through northeast Victoria through to just south of Dubbo. And over time and working with that collective group, we've established some really good peer learning. So we go through, soil pits, paddock walks, really fundamental basics around good farming, and then identifying and setting up the conditions that then enable those farmers to come up with their own ideas on how they can make change. So really that really classic trust relationship building, boots on ground, all the way through to rigorous data collection and interpretation.
And Sandy, from a Mars Petcare perspective, why is it so important to have that insight and connection with growers?
It's important for different reasons. So first of all, we want to make sure we actually drive tangible impact in our supply chain. And in the longer term, I think it's not only important for our sustainability goals and us achieving our targets, but also at the end of the day, we are a food manufacturing business. We rely on agriculture and we are making the whole supply chain more resilient. So that's why this connection with our direct or not so direct supply chain and all the way to farmers is so important.
Cass, can you explain how you've engaged with farmers? My understanding, as you said, is you're first looking to get that visibility of what farmers are doing on farm at the moment and some sort of idea of what their current greenhouse gas emissions are before you move on, as you say, with those grower-led sort of changes in practice. Is that right?
That's right. So we really set the scene to work out what's happening. We ask farmers to be very descriptive around their inputs and their systems, and then we kind of learn together in that approach to see what their key levers are in terms of on-farm emission reductions, run the reality lens over that to say, well, how can different changes be implemented practically and profitably within their farming systems, and then kind of work with them on what changes might be possible. So we run a really kind of farmer-led engagement. But what's been really exciting is we've got over about 200 farmers on board with us so far, and all of them basically are saying, we want to continue working with you, and most of them are actually demonstrating that they're getting value out of what we're doing. So it's not just saying, here's a piece of paper, fill out a form, tick and flick through, as we've heard a bit today already, but how we can then really get that knowledge and interpretation back on farm to understand what it all means, and then keep kind of nudging the dial.
And can you explain how far the initiative has come since, I guess you were telling me it started on some beer coasters many years ago, or not many, but a few years ago now. How far has it come since then, and what have been some of the biggest challenges that you've had to overcome as well?
Yeah, so we started 5 years ago with Mars Petcare in partnership with the Sustainable Food Lab in Vermont. And it was effectively 4 of us sitting at the Forbes RSL after a day of talking to farmers and riding on beer coasters. And the whole thing has evolved from there. And that really pulled out some of the key elements that we wanted to work through. Then we spent the next 2 years with support from Mars, starting to work with farmers and identifying that we didn't actually know at that point what the best pathway forward was. We just had to start so that we could start that iterative learning. And then from there, we've continued to build sophistication and complexity and connectivity into the global world from that. So we've really gone from, we started our first year with 20 farmers across that supply shed with Mars, and 5 years later, we've had some really good, strong investment from our 6 corporate partners to date, Mars, Kellogg's, Manildra Group, Allied Pinnacle, Corson and PepsiCo. and support, really strong support with CSU as our researcher and host, and then the Food Agility funding over the last 3 years. So we're now at the point where we've identified some really key blockers and dealt through with them in terms of how we bring value back to farmers without actually a pay-for-practice approach, how we actually connect between the international requirements for Scope 3 guidance and international calculators for greenhouse gas emissions, and bringing those back into the Australian context through regionalisation of those tools, how we ensure that we have strong connectivity through what we're doing on farm, what we're reporting on farm, and then through to value back to our supply chain partners, and how do we communicate, ensure we communicate through to our supply chain partners the reality of our farming systems and kind of the key wins that we're doing. So really there's, complete communications all the way, but really strong feedback as well. So the farmers are really keen to know what their supply chain partners need to ensure that we're all on the same page.
So you've sort of had to pioneer a whole new framework in a
We have.
sense. Sandy, from your perspective, what's the journey been like over the last 5 years to where you are today?
Well, I think the initial challenge for us was that our supplier base changes over time. And the suppliers we worked with back then are no longer our suppliers today, or it's been on and off. But the supply chain remained the same. So I think this is where the Cool Soil initiative is quite unique, is that we work directly with farmers, even if our supply base changes over time. I like that you said it's an iterative journey, because I think most of the time, especially for FMCGs, the hardest part is to take the first step, because you're trying to figure things out as you go. You don't necessarily know what processes, what system, how do we measure, who's involved, et cetera, et cetera. So taking that first step and trying, and sometimes failing, because we try things that don't always work, to be honest, I think is really important, and building on those learnings, and we'll keep building on what we've learned in the future. So very much an iterative process. We had not everything figured out from day one. I think that's for sure. Yeah.
And it seems like collaboration across the supply chain and that sharing of knowledge in both directions is really central to the program. How does that work? And I guess, what have been some of the challenges with that? You've got multiple partners on board, as you said now. Cass, we'll start with you. What's that like?
I guess the first challenge is that every company is not just at a different place in the supply chain, but also a different place as far as their expectations and their alignment with how deeply they've thought about this. Some of our partners have been very strongly in the sustainability and reporting space for several years, and others are just getting a handle on what that means for them. The other thing is identifying what's happening in America and Europe, and the interventions or implementations in place globally. A lot of those actually don't work for our systems, so how we actually create our own space there has been really challenging. But I think one of the most liberating things out of the last 5 years has been to work with a collective of corporates, a university and a funder, in a way that we're all towards that common good for industry, and acknowledgement that if every company were to try and do this by themselves, not only would they be in for a rough time as far as having to learn from scratch, but also every farmer contributes goods through multiple supply chains. So there's the risk and chaos that could happen if every company is asking for information of variable quality and integrity as that comes through. So to work with such a collective that is so collaborative and industry good focused has been probably one of the most liberating as far as capacity to build. And there's nothing impossible. We just have a crack and start, and then we learn from there.
Yeah, absolutely. And Sandy, you can add to that.
Yeah, I think it's the true value of the Cool Soil initiative. It's really this end-to-end collaboration, and we have workshops, face-to-face workshops here on campus with farmers, grain traders, processors, and food manufacturers, and all being in the same room and trying to, well, have a crack and figure out the best way to proceed with the initiative is, I think, the real value. And it's also challenging because we have conflicting views sometimes, but just clarifying those challenges and trying to find a way to solve these problems together, I think is the real value of the initiative for me, yeah.
Yeah, because I guess you're competitors with some of the other partners as well. So it's this really collaborative space, but I guess that makes sense because, as you say, your suppliers change all the time and who's growing for you. So it's lifting that whole industry up in a sense. Cass, can you tell us one of the sort of most successful examples you've had out of the Cool Soil initiative, I guess particularly from a farmer perspective?
So we work very much directly with farmers in every region, and you kind of go through the whole process of what's happening on ground and then what that all means. So even though our long-term goal is to be able to demonstrate and continually improve our sustainable farming systems, sometimes we actually have to work at a really low base to do that. And so rather than saying you need to be low emission farmers, you need to demonstrate this and this, we actually say, well, what's the limiters in that system? So a really good example of that is in some of our farming systems have become highly acid. Our soils have become acid. Some were naturally acid, some have got more so over time. And that soil acidity actually limits the crop rotation options, particularly the roller legumes. We know that as we go through the process that improving the amount of legume in the system is the only way to build organic carbon into the long term. And so rather than focusing on low emissions, we focus on what's the key constraints in your farming system and identifying those, working with those. And then if that addressing soil acidity means you can grow in legumes, growing legumes well means that you can get a good place for the rotation, peer learning around marketing and value, and then all the way through to being able to support more sustainable nitrogen fertiliser usage. So, and we've been able to demonstrate over time that we have had a significant impact on the incorporation of lime and soil acidity, and then linking into improved legume use in our systems.
It's obviously good for profits as well.
Yeah, exactly. And that's key, is we're not talking about low emission farming or carbon farming. We're talking about how do we support sustainable good farming, knowing that the better we can grow our plant, the more efficient we can utilise our inputs, the more tonnages we can sustainably achieve, and through that whole process kind of supporting consistent low emissions and maintaining or potentially improving our soil carbon values. So it's all the same story. It's a triple win.
Yeah, absolutely. It sounds like it's an exciting time for the program. Can you tell us what's next?
So we've just finished our last 3-year funding with Food Agility CRC input, and from now going forward, we're building into a longer term structure with our foundation corporate partners and CSU, and seeing how we can look to build that into an enduring program that can continue to build with ongoing industry and corporate investment, so it becomes a whole of industry, almost business as usual approach. So that's exciting.
Very exciting. Well, thank you so much, Dr. Cassandra, Schefe, and also Sandy Game for joining us on the panel. Please thank them for me.
Absolutely.
Thank you. Up next is Ben Harris, the Regional Viticulture Manager at Treasury Wine Estates, to give us an overview about how the winery has adopted ag tech across their operations. Please welcome Ben.
Thanks, Olivia. I'm Ben Harris. I'm based at Winson in Coonawarra, but I oversee our company vineyards in Australia and New Zealand, as well as our technical team and strategy. Today I'm just going to talk just a general overview of Treasury and then the key areas we believe we need to focus in going forward for what vineyards will look like in the future, and then just a couple of examples. So, Treasury, our ambition is to be the world's most admired premium wine company, and the way we want to do that is we want to boldly lead change in the wine world. We're custodians of globally known, renowned brands such as Wynns, Penfolds in Australia, Matura in New Zealand, Gabbiano in Italy, and Beringer in the US. we have a global supply chain with vineyards, wineries and growers in Australia, the US, New Zealand, France and Italy. I'll be mainly focusing on Australia and New Zealand today, but what this global footprint does, it enables us to try a lot of new tech and a lot of new innovation globally, fail fast but also learn fast, and then where appropriate scale up. Here's just a short video just of our vineyard assets as well as some of the innovation and technology. So the vineyard of the future. So we've where to focus, and so we've grouped it into, they all overlap. So the reason why we don't have them in columns is because a lot of the initiatives, I suppose, tick a few of these categories. But people and systems, you know, you can't innovate and you can't approach new technology if you don't have the right culture. You know, there's been a lot of talk today about digital platforms enable us to share and exchange data, to basically collect and manage large data, and also training and development. In the automation space, which is a key focus, robotics, you know, irrigation scheduling, passive data collection. You know, how do we stop unnecessary administration and spend more time on the insights that data give us and meaningful action and real-time insights. So basically enable our team with insights around the impact financially on quality, on yields of every decision they make. Climate mitigation, we're seeing a variable climate, so how do we react in the short term with seasonal variability, but also how to react with long-term impacts of climate change. You know, water's key. Climate insights, long and short term, and how do we plan and react and base our planning on climate scenarios. Controlled environment, what tools do we have to mitigate against the impact of frost, impact of poor flowering conditions, which impacts our yield and quality, heat events, not enough rain at some times of the year and too much rain at other times. So, and then, you know, our planting material, including breeding, disease-resistant varieties are also a focus. How do we build resilience in our vineyards through soil carbon, soil health and vine health improvements, sustainability, water, biosecurity can't be underestimated, and the importance of biosecurity is key. We're focusing on regenerative viticulture. Once again, planting material, renewable energy and alternative fuels, and also the people and the communities that we live and work. And enablers for us are long-term planning, bold innovation, digital platforms, and also we don't have the skill set to do all of this, so who do we partner with to enable it? Okay, so how has TW used digitally driven insight systems and tools to increase value across our supply chain? One example is a partnership that we have with the Yield, and it focuses on two areas: climate insights, being 14-day weather predictions for each of our vineyards, as well as 180-day weather predictions for all our sites. And the other being data analytics, machine learning for our yields for growth stage and harvest timing predictions for all our Australian and New Zealand vineyards, which is greater than 1,500 blocks across. So climate insight. So it's really about us having a site-based long-range forecast, giving us time to plan and react, as well as secure the resources required. Obviously, there's a lot of weather apps available, but for us to have one consistent point of truth, like the weather may change, the weather forecasting may be wrong, but one consistent set of data that we all can react to. And so, you know, the 14-day predictions around heat events, around rainfall and harvest timing is key. And then the 180-day weather outlook for each of our sites is used in a couple of ways. One is, you know, enable our managers to be less conservative and react to the season, because it's data-based, not experience-based. So, you know, an example was last year we had a cooler, wetter season than normal. We knew that. There was obviously the obvious climate drivers, but the 180 days showed us when it was going to be more wetter than average, when it was going to be cooler, and as a result we modified yields because we knew that we couldn't carry heavy yields with a cooler year, and also we removed a lot of leaf which in a hot year could result in sunburn, but you know, managers actually did a lot of leaf plucking and a lot of practices that we wouldn't normally do. The other tool is we call it analogue years. We basically use the climate observations to date and then that 180-day forecast to predict a like year. So for example, in a lot of South Australian regions, our analogue year is 2018 for this coming vintage. So what we do then is we go back at 2018 and what were the learnings from that vintage? What worked well, what didn't do well? How do we need to manage our vineyards to outperform when we had a vintage with those previous conditions? Data analytics, machine learning. So we basically use the yields machine learning models that leverages, we've got longer than 23, so we've got 23. We've got quite an old database system that manages all our operations from vineyard through to the winery operations to the end wine. And you know, we are data rich, but it's only till now we're starting to get the tools that unlocks that full potential of that data. And so we basically use this data set along with climate data and satellite data to predict our yields for our key growth stages and harvest timing across all our blocks. And this is automatically updated every 14 days, and through harvest this year will be updated daily. And these predictions also start 18 months before harvest at bud initiation. So we used to start yield forecasting at pruning. We'd look at bud dissections and look at our fruitfulness and then start determining the yield potential. But we now start in November, December, because the climate conditions, you know, influence our bud initiation and yield potential, and so we start factoring in yield estimation. And we look at it not so much in, I suppose, snapshots throughout the season, but alive. So as the weather forecast changes, the weather observations change, so does our yield at a block level. And these models provide insights based on the climate drivers, weather observations, and help create block-specific insights that guide our management decisions, our intake planning to help optimise vineyard performance, vintage logistics, as well as our supply and demand planning. Just a couple of quick acknowledgements. A lot of this work stemmed from some CRC projects, so I just want to acknowledge all those and what we're doing, I suppose, is a commercial reality. Thank you.
Dr Stéphanie Camarena is a Food Agility alumni and is our next showcase presenter, here to discuss AI in agriculture. From missed responsibilities to realised opportunities. Please welcome Stéphanie.
I managed to put a cross just to annoy people. I want to profit and replace my prosperity. Actually, thank you very much for inviting me to talk today. I've been given a license to be a little bit of a provocation piece today, so I'm going to use that. I'll present you with some questions that go beyond the boundaries of an organization to that of the benefit of the whole, the food industry and beyond. So bear with me. There's some of the subject that might be confronting, or you might be wondering, what does that apply to me? What's the link? But they do relate, and I'll discuss how we can create opportunities out of facing into those responsibilities. So yeah, my name is Stéphanie Camarena. I help businesses engage and navigate AI for sustainability impact. And I'll talk today on AI in food systems. So from production, packaging, transportation to distribution, food consumption, food waste, AI is transforming the sector as a whole. We see automated detection of lice on fish, precision agriculture, planning and monitoring of crops and efficiency, robotics, traceability of the supply chain. AI-powered solutions are no doubt crossing your life and changing the way you're working. We hear things like AI can lower the environmental impact, automation will help with workforce challenges, or with speed or accuracy. AI will increase profits. When we look at AI used in agri-food system, there are some things that are missing from the conversation, though. How do we realize the environmental opportunities? Kate Crawford, who is a researcher in AI and at Microsoft too, said AI is neither artificial nor intelligent. I like that quote. In the background here is a graphical representation of her work on what is under the hood of a simple AI device. AI is not artificial. It requires material resources to produce the hardware needed to make AI work. Servers, computers, chips all require intensive mining, the use of fossil fuels, energy, water to manufacture and to operate. The machines are hosted in data centers which use lots of water and power to cool down the machines. So when we say AI in agri-food can help better detect diseases, pests, help reduce water, the usage of fertilizer, or reduce the use of water, I have to ask a question and see. Anyone here has ever used ChatGPT? I have. So research shows that when asking 20 to 50 questions to ChatGPT, you use 500 milliliters of clean water. Multiply that by the number of people asking these questions globally. I'll let you do the count. This is not sustainable. The environmental benefits of AI need to be contrasted against its environmental footprint for them to be real. When we take the impacts of AI technologies into consideration, and we really devise and conceive of solutions that will help us really make significant progress in terms of environmental outcomes, not just marketing ones, balancing the two. How do we realize the social opportunities? So I'll go back to the quote from Kate Crawford, where AI is not intelligent. We see that it could help resolve human labor challenges, but it also creates new ones. It's people who are performing the tasks to make systems appear autonomous. It's people who label the data that goes into the training models. While a 2-year-old can learn what a dog is after you showed them once or twice what a dog is, for AI, you need to give thousands and thousands of images of dogs that have been labeled by someone saying this image is an image of a dog. So it's a very time-consuming exercise, and it's also fraught by bias and discrimination. This labeling exercise is often done by people paid very little and working in bad condition, a type of modern slavery we need to be aware of. These are just a few examples of recent articles on that subject. We talk about automation and the possibility of replacing part of the workforce. There are many ways to use automation in agri-food systems. For example, we could use AI to basically replace agronomists completely, providing advice and decision-making support instantly. However, there are something else in there. There are relationships that are important, relationships that at times would alleviate a bit of the isolation. Relationship will help linked to the people's knowledge and wisdom, not just data and information. So we need to reflect on the decision to use automation based on what is right for the context. Yes, in terms of profit, but also in terms of well-being and health. So let's not miss out on our responsibility to consider the people dimension. We can realize benefits when we conceive and design solutions that innovate in the right places, not at the cost of human dignity, human wisdom, or human health. How do we realize the economic opportunities? AI will help reduce food production costs, improve crop yield, or agricultural efficiencies. That is all true. But I ask who for? Solutions available today often developed based on data sets coming from big data, mostly from a monoculture context. It makes total sense. It's easier to train models on data from monoculture and big farms, because smaller farms and with diverse crops or mixed crops do not have enough data, or they do not have the budgets to train models, not on their own. It's a fact that big data is where big investments are available. Therefore, this is the context that the solutions are developed for. This puts the industry at risk of further providing competitive advantage to bigger operators, leaving behind smaller and medium ones. Is that what we want? Do we care? Maybe the response is yes, but I'm asking the question. Understanding who benefits, what power the technology serves, is important when you think at the industry level, but also for all economic actors. Decision-making tools should come from diverse profiles, diverse backgrounds, and informed by transdisciplinary approaches, because it leads to more robust solutions. It reduces the risk of bias and discrimination in AI. It reduces your reputational risk, and it increases your ability to innovate. Economic opportunities are also based on good decision-making. So when the AI solutions we use to make decisions are trained on data and labels from overseas, they do not represent the Australian context. They might reflect the US or the European context more likely. Therefore, the advice provided will not be adapted to what we actually need. So understanding the data context is also an important consideration to ensure economic benefits can be realized. When we take responsibility for who and what is represented in the solutions that we develop, we guide innovation towards a more diverse and resilient food industry. We talk about how AI can benefit exporters, producers, and suppliers, but we're missing a critical element: the customers, the market demand. What does the market demand today, and what will it demand tomorrow? For example, there is a demand-driven market to lower food waste, and a regulatory one too, actually, to have full traceability of the produce. There is a demand for a shorter, more resilient, transparent supply chain. We need to adapt quickly to rapid changes in demand. To need to integrate the need for climate mitigation and adaptation, to care for how we grow food, how we breed cattle, without destabilizing the surrounding ecosystems. It's not enough to look at AI for what it could do for us individually. We need to adopt human-centered, customer-centric, future-proof sustainable solutions. We can help agri-food systems transform and adapt more rapidly to become more agile. So in conclusion, I'll leave you with this. To realize the benefits of AI, to really realize them, we need to really take responsibility because it drives us to identify what data does not exist yet that should probably be captured so that we can transform our relationship to the environment while we reach for prosperity. When we find ways of measuring the costs and benefits outside of our organizational boundaries, we create AI-enabled, boundary-spanning tools that are critical to innovation and to sustainable transitions. Thinking of responsible automation in agri-food systems forces us to rethink where the place of the human is, where the place of the human should remain, and what is the healthy and connected way of approaching automation ethically and responsibly. Finally, I'm done. Engaging with AI responsibly gives us many opportunities to use that collective wisdom to drive innovation that is actually future-proof, ethical, and lowers the risk of damaging the future of agri-food systems in Australia. I hope this provocation will give you a little bit of an insight of the type of things that I annoyed my clients with. And I'm happy to answer any questions anytime when you see me around. Thank you.
Please now welcome to the stage Dr Warwick Badgery, Research Leader of Rangelands and Tropical Pastures at New South Wales DPI, who will provide an overview of Grazing Intelligence, a food agility CRC-backed project in collaboration with New South Wales DPI and Pasture.io. Welcome, Warwick.
Thank you. Today I'm going to present some work we've been working on for quite a while, and the last 2 years with the Food Agility CRC. My co-author Igor Karliski is here today as well and can help answer some of the more technical questions around the modelling that I'll present today. This is a partnership with Pasture.io, who we've been partnering with to not only access satellite imagery for pasture projections, but also to display data through their software. So one of the key things that we're trying to do with Grazing Intelligence is to improve the confidence in grazing decisions for producers. And so that's got two elements to it. The first is around assessing the pasture that the grazing livestock will have access to, and then also the livestock performance that will result from grazing that pasture. So there's a few tools that are available to help with farmers to make these decisions, but most of this information is not linked together. So we've got things like satellite imagery, pasture predictions, we've got some animal weights when they come into the yards, and we've got things like walkover weighing or OptiWeigh, which is starting to become available. But they're discrete bits of data that don't give you the full picture you need to make these decisions. So in the end, the farmer makes a subjective decision, and they put it together on something like this, a whiteboard. Some of them might have a digital version of this, but in the end, it's still the farmer aggregating those separate bits of information and making those decisions independently. And I think most farmers can relate to this situation. So one of the things that we're looking to improve the confidence on is, first of all, when we've got animals in individual paddocks, when we should move them to a new paddock to maintain a given level of production for those livestock. And then if we do need to move them to other paddocks, where on the farm should we move them? It's not always the paddock with the most grass if we're looking at livestock performance, because we've got quality aspects of pasture. When our feed starts to become limiting, we need to look at where we prioritise that limited feed. So which livestock are we going to put on what areas? And if we do need to start supplementing, when do we actually do that? And how much supplement do we actually need for those animals? And all that needs to be pulled together so that we can actually improve farm profits. The other thing when we've done some talking to farmers about this is they want these projections at a paddock scale, they want them daily, and then they want those insights aggregated up to a whole farm. The other thing that they've told us is they don't want another standalone app. They want this integrated with the farm software that they currently make decisions with. And so they want that information available through those farm platforms. So with the Food Agility CRC project, we've developed this Grazing Intelligence project. And these are the elements that we've got, which is basically displaying developing some machine learning models, using some APIs to connect them with farm software, then validating those with some farm data, and then looking at what is the business plan that would support this. So the opportunity that we've had is that we've got a series of research stations across the state where we've run livestock systems and we've had long-term grazing trials, and we've been able to access that data from four main research stations at the first point, and some historic data from a few other sites. We've continued to collect farm data on pastures across those research stations, and up here on your right you'll see a map of the Training Agriculture Research Station and a subset of the pasture points that we've actually collected over time. So we're up to about 94,000 pasture points that we've collected that is aligned with animal data. That's about 4,300 individual sessions. 72,000 animal weights that we've integrated and are matched to those pasture assessments. And that comes together at over 2,000 grazing events in 191 separate paddocks that we've used to inform this decision making. So predicting pastures, the way that we do this is we take sentinel satellite imagery. We take some understanding about the soil properties for paddock boundaries and property boundaries, and then we integrate that with weather data, and we use a machine learning approach to predict some pasture properties. So that's not overly new. There's a few providers out there who are providing this same information for feed on offer, which is your green and your dry biomass. But we've started to develop some new different pasture functional types, and because of their relationship with livestock production. So we're looking at things like the functional groups of pasture that are actually related to animal performance. We're looking at things like vegetation height and structure, cover, and pasture growth, and pasture growth of individual components within a pasture. And so it's predicting these from a machine learning approach. Then when it comes to predicting animal performance, we take those pasture properties that we've got and we combine those with the other things that we're using to predict those pasture properties, and then we can look at how those actually improve predict livestock performance. And so the key thing that we're trying to hone in on, which is missing at the moment, is the grazed quality. So we know what is related to pasture quality often in the field, but we've got these animals that are actually interacting with that pasture as well. And they've got selectivity at a landscape paddock scale, and they've also got selectivity at a patch scale. And so we need to take that into account. And so the animal is the actual integrator that we use. And what we're trying to predict is the animal performance or the weight change of those animals. So just with the limited time I've got today, I'll just talk about one of the pasture properties that we've predicted, and this is where we've looked at the selective grazing of individual plant species components and put together a model that actually predicts that selectivity component. And this has actually become a a very important part of our animal modelling component. So it's not just biomass, but taking down to that next level of what are the animals actually eating in that pasture, and then ranking that in order. And here we've formed it up into 5 different functional types. Then looking at animal performance, if we just use pasture dry matter to try and predict animal performance, what we find is it's a very coarse relationship, and it doesn't have a lot of predictive ability. So if we then, say, bring in something like the green component of the pasture and the total biomass, it improves it a little bit, but we still don't have a great predictive performance. But once we build in all these data levels that we've got access to, the accuracy of our predictions actually increases quite a bit. And so it shows that these machine learning approaches, if you can think about it from what's needed to describe that livestock performance, and we can actually feed that into the models and then test that against a sub-series of data, then we can actually improve those livestock predictions. So just in conclusion, what we've done is we've been able to remotely predict dry matter, the feed on offer, and then functional groups of pasture species. And we've done it a number of different ways. We've tested the pasture model accuracy in contrasting environments across our research station. We've developed an animal model from that experimental data and from commercial paddock data. We've established the APIs to link that with the Pasture.io software, and we've also established our first demonstration site on a commercial farm to start testing this, and we plan to, in another project that's rolling on from this, to start testing this in a lot of other different environments. Next thing we need to do is validate in a lot more environments to ensure that we've got the level of prediction that we need, and integrate with some other input data that we think is going to be useful, things like walkover weighing and GPS ear tags, and then, try and get this delivered as a commercial service. Thank you.
Up next is Result Group's General Manager, Michael Dossor, who will provide an overview of an industry-wide collaboration to establish traceability in the Australian table grape industry. Please welcome Michael.
Thank you very much for having me. My name's Michael. My friends call me Doss, so if we're staring at the stars tonight, please feel free to say g'day, Doss. Result Group is a company that I'm very proud of and very proud of the team of. We operate in 4 business areas. So product identification, which is coding and marking, labelling and those sorts of things, which is paramount to delivering traceability in any sort of manufacturing or fresh produce or agricultural environment. Process automation, which is where all of our traceability build has come from. What I'm going to show you and go through with you today is something that is real, that has happened and is beyond pilot stage and is deployable. Traceability can happen right now. We work in a couple of other areas around value-added packaging, and we do a lot of work with self-adhesive materials. But what I wanted to start with as far as traceability is concerned was some key takeaways. Probably because I might run out of time within 10 minutes, so I'm going to start with those. Traceability without fear. There's not just Result Group, there are other traceability solution providers in this country, and we are doing the work right now. It can be done. In fact, when we start to look around the rest of those circles and pulling out those key takeaways, this is where it becomes critical. Standards are critical. The standards exist right now. There's an organisation called GS1. Everything that we touch that goes boop at the supermarket has got a GS1 G10 on it. That operates all around the world. Those extensions extend further down the track to SSC labelling, which identifies pallets, to trade unit numbers, which identifies crates. If we work within those standards, the ability to roll out interoperability, all of those sorts of things, and not introduce major change to the people that we need to interact with the traceability systems becomes so much more easier. It's that simple. The job, a lot of it, is already being done. What we're doing is harvesting data from those existing systems and linking it together, and that's the real tricky part that we've all solved. Protecting your brand or your reputation It's coming. I would hazard to say that we have a lot of work to do in this country in this traceability side of things. So I go back to traceability without fear, because we're not the only market that's working on it. They're working on it all around the world. And if we sit on our hands and knees and we don't protect our brand or Brand Australia, that 120, these big numbers that you guys are talking about as far as targets are concerned, we're actually not going to get there, because other export markets are going to be in front of us. So we can't sit on our hands and knees. So we're protecting the brand, and guess what? It can all be done without major change to process. Believe me, the operations manager at the plant that we worked with Perfection Fresh, when I first walked onto his site, he said to me, "Doss, if you slow us down or you change our process, I'm going to lock you in the freezer." And he was dead serious. Now, I'm still standing here, so we got through it. So it can be done without massive change to process. So this is the pilot that we did for table grapes. We went across the entire season, and we went out to 15 export markets all around the Asia-Pacific area. If we could play the video right now, guys, this is probably the best way for me to tell you that story.
So my name's Michael Dossor. I'm the General Manager of Result Group. We're the technology partner in this project, rolling out the traceability platforms, labelling technology, and also linking to the cool chain tracking systems. The QR code is based on GS1 Digital Link symbology, and it's applied to every product, unit and case level. The code itself is massively important, because all of the data that is sitting behind it is from the grower's existing systems. Data is taken from the existing systems within the growers' networks, and it's associated within the Everything Product Cloud. The GS1 Digital Link is one of the brightest innovations going around in our industry space. What it enables is everybody to use the one code for a bunch of different purposes, whether that be the consumer engaging with the QR code on their smartphone, whether that be the supply chain scanning it for the data that they need of product going in and out of various locations. This enables a seamless connection with supply chains and also consumers all around the whole world. The technology is very easy to use. All consumers and supply chain partners with a smartphone can integrate and work with the platform now. No special app is required. Through the scan, customers can access detailed information about the grower, about the farm, its location, the harvest, and also about the variety of the grapes. This helps the customer visualise and know where their food has come from and the safety and the quality that goes with that very food. They can also participate in very simple surveys that will give both the industry and the grower feedback on the fruit. So this puts the power of validation in those that matter most. The consumer, of course, but also the supply chain partners, the importers, the retailers, everybody involved in the supply chain. The GS1 standards will future-proof the industry. The export regulations are evolving. This is going to play a key part in those going forward. So having the GS1 standards is a critical element. Standards are critical to everything that we do. International capabilities and compatibility, it's key. When we're working with so many areas of the supply chain, if we have standards, then it enables us to all follow and share the data, and that's very important to the journey that we're actually going on.
Do you think I said the word standards enough in there? And sorry to play a video of myself when I'm actually on myself talking on a stage, which is a bit weird as well, isn't it? Anyway, we'll see how we go. Look, what I am going to bang on about standards, because standards do this. Standard keeps grower investment to an absolute minimum. It doesn't mean that we can't innovate with what we do in the back end. In that particular project, there was some talk around what will systems give a farmer back. In this particular pilot, we had 4 farms all growing the same grapes. That little survey that you saw up there, which is straight from the consumer, went back and we carved that data up for the marketing team at Perfection. We also carved it up for the farming team as well. And what we were able to say is that the consumers liked a particular variety of grape more from this farm versus this farm. What the operations team was actually able to do was then go and drill down on that and say, okay, why? What are we doing different at this farm than we are at this farm? Or are they things that are beyond our control? Should we be looking at growing more of this variety grape at this particular farm versus the other one? Business decisions that came from real data from people that matter the most. So these are the touch points, the digital identity that is created with it, the end-to-end traceability that comes with it, the product transformation. Guess what? We get that today you've got to send a container of product to Vietnam and tomorrow you've got to air freight 4 boxes. So we've got to be able to have systems that can deal with that in a warehouse environment in a seamless way. It has been done. Raw material tracking, farm and origin data is obviously extremely important, and what we collect versus what we share is two different things. You might have seen up there, and that video is on the result website, it's passed all over the ATGA website as well, you will see that the data or the information that we display is fresh. We don't show the fact that we've tracked with and we've tied in the data of every supply chain transaction and temperature, humidity for that whole process. We share with the consumer that's fresh. So we do have control over what we share and what we don't share. Ultimately, from a consumer experience, we did learn that B2B transactions and B2C transactions are just as important as each other in export markets. When a product changes hands and goes from one buyer to another, particularly in a market like China, where as you go deeper into the country, it might be going through more hands, that validation or authenticity of that transaction is just as important as what it is in the consumer's hands. So that was a very valuable learning that came out of it. The other one was that here in Australia, we don't scan too many things yet, but in Asia, they scan a lot. So something that we should be really proud of, and not just because it's our business that built it, we were lucky enough to be involved in the project, but we collaborated with a bunch of different people in a bunch of different ways. And this year, that Australian technology traceability platform won a World Star Packaging Award. It was the only piece of technology to win a World Star Packaging Award, and that was for the fruit and vegetable sector. And that's something that we should all be extremely proud of and leverage off with what we're doing going forward. Key challenges and learning. Data sharing, I touched on that. Packaging development, making sure that we're not changing anything in that manufacturing environment. The lock in the freezer story that I told you about earlier. Deep collaboration with vendors. What we understand, or what we now understand after working in this project, is it's not all about the Telstras and the big companies of the world. It's also about the smaller software vendors that work in particular markets or have developed products for particular markets, and we might need to take data with them. So we've got to learn to work with them. We've got to understand we're not trying to replace their products, we're actually trying to collaborate with them. That's a very important learning that comes out of it. And it's not just about marketing outcomes, it's also about operational outcomes as well. And let's not lose sight of that. So hopefully I've given you a few examples. I've gone a bit over time. I'm really sorry, ladies. That's it. I'm done. Thank you.
Next up, we have Senior Research Fellow at UTS, Dr Penelope Ajani, who is here to discuss the Food Agility-backed project, Transforming the Australian Shellfish Production. Please welcome Dr Penelope.
Thank you. Thanks for inviting me here today to present our work. I'd like to shift you all from Wagga Wagga over to the coast. I'd like to put a plate of freshly shucked oysters in front of you and a glass of chilled white wine and potatoes. You work it out which is the best food. But our project is called Transforming Australian Shellfish. This is a total collaboration. It's led by the University of Technology, Sydney, of which I'm a part of with Professor Shauna Murray. But our project partners are the Department of Primary Industries, New South Wales Department of Primary Industries, that's the Food Authority, and the fisheries departments, New South Wales farmers. We're also working with the WA Department of Primary Industries, and of course the Food Agility CRC. And this is our lovely group of collaborators, and I just really want to acknowledge them up front because we've been working really successfully together for the last 6-7 years. Excuse my throat, I have a bit of a, not COVID, but a bit of a throat problem. Just a bit of background to this. The oyster industry is, shellfish across Australia is valued at $85 million. That may not seem too much to you guys, but the majority of that is focused along the New South Wales coastline, and that's valued at $53 million. The Sydney rock oyster is native to Australia, and it's been commercially farmed for over 150 years. And so when I mentioned the value at 85 million, it may not seem such a lot, but it has incredible cultural, environmental and social benefits to a lot of New South Wales coastal communities. And we've also currently, or just recently started working with the WA shellfish industry, and they have incredible, an incredible aim to expand their product in terms of species and locations along the huge coastline of Western Australia. So we're working with Harvest Road over in Oyster Bay. But while I still think they're better than potatoes, oysters are a very high-risk food group. So they're susceptible to poor water quality, anything that's coming into the estuary, and that includes nutrients, fertilisers, cow poo, bird poo, everything that comes into that estuary affects the oysters. And of course, because of health regulations, excuse me, and the Food Authority, if there's any doubt in any issue, then the harvest area will be closed down until those farmers can, prove that either the water or their oysters are safe to eat. But the problem with all of this is that the testing is difficult. It requires specialised laboratories, and often the results can be slow. So the harvest area might get shut down for at least a week before results can become available, and those results may say that the oysters in fact were clean. So the farmers can lose up to a week, which is estimated to cost about $100,000 for each one of those closures. I didn't mention that the management plans are presently run on rainfall closure. So if there is a certain amount of rainfall, the oyster harvest is closed down until they can prove that their product is clean. This inset here shows a picture of a bloom, a toxic algal bloom. So algae are the phytoplankton that live in marine, estuarine and rivers. Some of them can produce toxins that, once they bioaccumulate, can end up in the shellfish and can be very serious for us in mainly diarrhoea, vomiting, but can also end in amnesia, seizures, cancer, death. This bloom occurred in 2017. It was a toxic algal bloom where mussels were being harvested in Tasmania. The bloom is actually occurring in that photo, so the tricky thing with all of these is that you can't actually see the bloom. In a lot of cases, you cannot see what's happening. It looks fine. But in fact, there were 10 million cells per litre. I've got one, thank you, yeah. There were 10 million cells per litre of the particular toxic species Alexandrium catenella in the water at that time. And it ended in 140 milligrams per kilogram of paralytic shellfish toxin in the blue mussels, which was 175 times the safe limit. So regular testing of these waterways where we're growing oysters and mussels is an imperative. The problem with the closing of the harvest areas when in fact the product may be clean is the issue that we wanted to try and solve. And what we came up with all these collaborators was to use real-time sensors which are located within the harvest area, not rainfall gauges that can be kilometres away from the actual harvest area itself, and combining them with molecular methods. So we've all heard of PCR now with COVID. qPCR is just quantifying. So it's the same as a qPCR test for COVID will give you a positive or a negative. The qPCR will give you how much. So we wanted to develop those methods to detect bacteria, so different types of bacteria, whether it was coming from cows, birds or humans, or just general E. coli, and also qPCR tests for harmful species, harmful algae species. And we also wanted to develop models that we could incorporate into apps for the farmers, and the aim overall was to improve and innovate the existing programs and to provide better informed and responsive management. So we've gone through 2 stages. The first stage started in 2018, where we've spent 2 years collecting high-resolution data. So every week, we trained the oyster farmers. Sorry, we didn't train them every week. We trained the oyster farmers to collect samples every week for us over a 2-year period. They preserved them for DNA extraction down the track, and we deployed these salinity sensors into 14 estuaries along the New South Wales coastline and 1 estuary in Albany, Western Australia. We then brought this data back into the lab, and we've been going through a 2-year data analysis stage. We also deployed oysters in each of those estuaries, and we measured them for growth and mortality over that 2-year period. There's a video now that... Great, thanks. So yeah, that just showed the farmers and the really hard work that they did to help us with this project. We call it a citizen science project because of the effort that the farmers put in. The results to date are that 15 estuaries, both in New South Wales and Western Australia, are on board. The oyster farmers collected over 11,000 water samples, over 3,000 oyster samples for us, and they put in, close to 3,000 hours of unpaid work just to provide those samples through to us. Now that we've collated all the data, 19 estuaries, or harvest areas I should say, some estuaries have more than 1 harvest area, salinity-only management plans have been offered to them. If they don't take them up, they just revert back to their rainfall-only salinity management plans. 7 estuaries have taken up these plans and others are considering them. So often an estuary can be made up of multiple different companies, oyster companies, so they're talking amongst themselves at the moment and considering their options. 82% of the models that we've run with all this high resolution data, so that includes all the qPCR data and the high resolution physical data, has suggested that salinity is a better predictor than for bacteria and harmful algal blooms than rainfall, and that was our hypothesis to begin with. So we're pretty happy with that result. We've also had some economic assessment done of this project, and we've shown that across 3 case studies, we've got up to about 9% increase in return to farm gate value, and that equates to millions of dollars for the oyster farmers. We've also developed, it takes a long time, as you'll know from COVID, to develop qPCR assays, but over the last few years, we've developed assays which can decipher between the different types of bacteria. So now we can identify whether it's coming from cows, and councils can take appropriate action if that's the case, whether it's human bacteria and sewage issues. And we've also developed qPCRs for the major harmful algae, and we're actually working to multiplex them now, where we end up with 1 test for multiple species. We've produced reports for each of the estuaries, and we still have 6 more to go. And just to conclude, we think that this real-time sensing, salinity sensing, shows considerable promise. We think it will increase profitability, and we think our economic assessment has shown that. We're having ongoing discussions with app developers. There are a couple of app developers in the oyster industry space. They're pretty busy at the moment organising how they shift their harvest around, but they are using the real-time sensor data, and we'd like to introduce our models where the models are predictive. And we've had considerable co-benefits from this project. One is that we've got a very good open access curated data source of estuary data that we are happy to share with anybody. We have a bank of samples in the freezer of eDNA, environmental DNA, and we can go back and look at that eDNA at any point to investigate, for instance, an oyster disease or something. We were lucky enough to get before, during and after data for the catastrophic weather events that occurred in 2019-20, and there's not a lot of information globally about the effect of bushfires on estuaries, so that's an incredible data source. We've given the data to, I won't read them all out, but to multiple other studies, other people researching in this kind of estuarine coastal area. And we have, on the back of the success of this project, we've just secured funding to deploy these really robust oceanographic sensors, one into Jervis Bay and one into Twofold Bay, Eden. We did that at Christmas time this year. They've got all the bells and whistles on them, and they report all the data back in real time, and we're hoping that that assists the mussel farmers to expand their industry in a very sustainable and resilient way into the future. Thank you.
Our next presentation is about a food agility and Charles Sturt University project in collaboration with UTS, which aim to answer the age-old question of connectivity on farm and ended up with perhaps a little bit more than they bargained for. I welcome to the stage Co-Director, RF and Communications Technologies Lab, Dr Negin Shariati, and CEO of Zetifi, Dan Winson.
Good afternoon. My name is Dan Winson, and I am the founder and CEO of Zetifi.
Hello, everyone. Thanks for joining this session. I'm Negin Shariati, co-director of RF and Communication Technologies Lab, and also senior lecturer at UTS. Also had a privilege working with food agility over the past 3 years as the Sensing Innovation Constellation Lead. Thank you.
I think most people in the room are well aware of the scale of the problem across Australia and in many other regions as far as in-field connectivity. So in this short talk, we're not going to go into all the details, But one thing that's become abundantly clear in the last few years in particular is that farmers need connectivity not just at home. Elon has that bit sorted, which is great. They need it out in their fields. They need it so they can adopt ag tech, so that they can have their phone working where they run their business, which is typically in the tractor. The problem is that in spite of Telstra doing an amazing job giving more than 99% of the population connectivity, that other 1% are the ones growing our food, and they live in the 66% of areas without coverage. So yeah, big problems right across Australia. 80% of New South Wales farms don't have adequate in-field connectivity, and that's the problem that Zetifi is committed to solving. We have a team of 30, and we've scaled that up, sort of doubling in size every year over the past 4 years. The solution that we've sort of developed to solve this problem is a hotspot for tractors. It's called the Zeti Rover, and it brings in the best available connection from the cellular network, and where necessary, it fills in the gaps using long-range Wi-Fi. And that's where we needed a bit of extra help, and we engaged with Food Agility, Sturt Uni, and of course UTS to help us design a system to extend Wi-Fi coverage across farms using novel antennas and RF systems.
Thanks, Dan. We had the opportunity to work on real-world challenges, thanks to Zetifi to introducing new challenges to us and also supporting us throughout this journey to achieve tangible and practical outcomes. Also here I want to thank my colleague at UTS. He's not here today, Dr. Rasul Keshavars. He brought his extensive industry knowledge and experience to this project to make sure we can create tangible and practical outcomes. Together, we developed new type of antennas, antenna array, and RF module systems for vehicular technology. We designed, simulated, tested our antenna arrays and RF module in RF City Lab at UTS. And we, first of all, we proved the concept, then we met the requirements of industry, and of course, we met Australian standards. We mainly focus on Wi-Fi and LTE band, and the antennas has different advantages. They are low profile, very compact, and we achieve high gain at all directions. And with these antennas, we could create an omnidirectional pattern. And at the end, cost matters. From day one, we had this in mind, or while we can have millions of research ideas, we should make sure that these ideas are practical and also the cost is down. So we could meet the requirements of Zetifi, and can go to the next.
Sure. So we're very fortunate to have support in this project also from Sturt University and the Global Digital Farm. As Negin said, they at UTS completed all of the testing that's possible in the lab and all of the simulations, but really the proof is in the pudding, and we needed to know that it was something we could build, deploy, and have it actually adoptable and usable on a farm. So having access to this amazing facility that many of you have had a chance to look at, for a startup, we're based here in Wagga, yeah, you can't describe how fortunate we are to have access to that size, that scale of farm, and for it to be a real working farm. So it means that we can get out there, we can do our scientific experiments and make sure that this technology is fit for purpose and that it works, and we can collect those data sets to show that we can actually take this to scale. Yeah, some more photos here.
Yes, we, with the support of Food Agility CRC and CSU and Zetifi, we've gone through field trial. As Dan mentioned, we got we finished our simulation and the fabrication and the test lab. We shouldn't get so excited, because at the end, which is really important, is to make sure our prototypes can work in real environment. There are lots of challenges, there are many unknowns. We should make sure our lab-based prototypes can meet those challenges in real environment. With Zetifi team and CSU, we could test our antennas in real environment, and we achieved great results in Global Digital Farm, which are in great agreement with lab-based measurements, simulation, and even theoretical analysis.
Exactly. So some really big impacts from this project. From an academic sense, UTS were able to create a paper and actually gave me a co-publisher credit, which is the first one I've ever received. Very exciting. Did not get a Guernsey to go and visit the conference in Italy, unfortunately, but yeah, the paper was accepted because this is truly novel work. more interesting for Zetifi even than the academic paper, though, is that we filed 2 patents around this technology. Those patents are providing us with protection globally to launch these products so that we can actually scale this up. We're too small to really make use of a patent, obviously. We're a startup, but it does help us win further funding, and really importantly, it helps us win grants and win capital. Raise capital. So yeah, in the 12 months after this project, we were awarded $3 million of state and Commonwealth funding to really get this out there in high volumes, not just for agriculture, but for other industries that need connectivity in rural and regional areas. And we raised $12 million of capital, which was led by Telstra. So we're working with Telstra to commercialise these products, make them available in high volumes right across Australia. The next steps for this project, the IP from this project is getting into the products that Zetifi are launching after raising that capital. The Zeti rover and our smart antennas are both available to be seen up at the conference centre up there, and you can talk to Rob and hear all about what we're doing with these products. And the research will continue.
Yeah, we had a very fruitful collaboration with Zetifi. I had the pleasure of working with Dan and his team directly. Over the past couple of years, we successfully completed 3 projects. And these 3 projects we mainly focus on average to high TRL, technology readiness level. It's very important for researchers to adopt their research based on industry needs. While we enjoy doing blue sky research to publish papers, we also need to tailor our research towards industry need and the Australia requirements. So over the past 2 years, we completed 3 projects. Those projects created a great foundation to pitch our ideas to ARC, and with QUT and other industry partners, we could secure significant funding over 10 million. So over the next 5 years, we can delve deep into communication challenges and automotive in regional Australia, and we can further enhance connectivity in remote areas.
If anyone is interested in learning more about the project or further collaboration opportunities around radio frequency technology, both Negin and I would be very happy to catch up. Our contact details are on the screen. Thank you.
Over to Dr. John Broster now, Senior Technical Officer of Herbicide Resistance at Sturt University and one of the project leads on a Food Agility CRC and Sturt University collaborative project with Mariota and IAG looking at the prevention of spontaneous haystack fires. Please welcome John.
Thank you. The hay industry, Australia-wide in 2020, was a $2.5 billion industry. That ranges from high-value export hay to lower-value, opportunistic hay made for drought reserves for farmers. Farmers spend a lot of time and effort into producing that hay and don't want that to happen. So, as part of the project, we involved with, as was mentioned, Mariota, IAG, involved in haystack fire prevention. So as I said, it's a significant, spontaneous combustion of hay is a significant economic and health risk for the producers. They put a lot of effort into it. They're not 100% sure it's going to go and mature. One year we were coming back from surveying for another project, and as we'd come over the hills to the north of Wagga, the question the two of us asked was, where are today's fires? It was averaging 2 a day in this area. Between 2019 and 2022, IAG processed 60 claims, Australia-wide, valued at 2.6 million from spontaneous combustion. It includes hay, but what else is also, where's hay stored? In sheds, and what also is also stored in those sheds? Farm equipment. So it's the loss there. And there's a complexity of processes involved in this heating and spontaneous combustion, which impact the producer's ability to safely store and manage that hay. And low-level heating that doesn't combust may impact the nutritional content of hay. The last experiment we did, we had hay up to 58 degrees, gradually cooling down. In 6 weeks, that hay lost 16% of its metabolisable energy, 35% of its fat, and 71% of the carbohydrates. So spontaneous combustion, there's lots of hay fires. They're not just through spontaneous combustion, but it's significant. It usually occurs within that first 6 weeks of baling. The major factor is the interaction of moisture and the sugar content. But other factors are involved as well. You've got bale size and type, the storage method. I was talking to one person just last week, and it's even the shape of the shed, whether it lets the hot, moist air out of the shed or not, can impact that. And environmental conditions. So the first stage we did, there's 2 commercially available hay sensors for temperature. So we tested one of them, put them in hay so that we could see that they were working. They link through Bluetooth to a sensor, data to the cloud, and then the farmer gets a readout of what the hay temperature is, and they can set in that alerts and they'll get an SMS message. We wanted to test, to start with, how good they were and how repeatable they were. So as you can see, they're the orange, probes you push in. You can see them in the picture, the haystack on the top right, but we've got other sensors there that we use for other scientific experiments just to see how good they were. And what we found, we had good consistency between the probes. If we put 4 in a haystack, in a bale, we got those sorts of results over a period. So that was good. It showed nice and consistent. If we looked at them with our scientific probes, which weren't as deep, so we were getting more ambient variation, we were still getting the same sort of trends. And when we had, and we did have a couple of ones giving weird results compared to the rest of the bales, our scientific probes, and there were 2 of them each side of one of those, were giving the same weird results. So we know the sensors are good. I made a throwaway comment at the start of this project. Haystack fires, we've got to have some fun. We've got to set fire to one. So we did. And we got the press here. And what we can see, it's the insulating properties of the hay. This is about a minute after one of the co-workers set fire to a few firelighters at one end. And what we got, we had sensors on the top, in between the 2 bales, on the ground and at the front. The arrow is when we set fire to it. The one on the side got up at this end. This is the western end, so the front end of this. Got up to 400 degrees, and where it dropped off is where it fell off. But look at the grey one. That's the one on the bottom. There's no temperature at all. When we go to the downwind side, because the wind was blowing away from us, we can see the one at the top got to 800 degrees in about 3 minutes before it fell off. The one on in the middle, where the heat was funneling through, got to about 700, stayed there for a long time. But also at that time, there was an area there where if I could have got around the rest, I could have put my hand on that bale and not felt any heat. The infrared sensor was saying it was 20 degrees. So we can't get an idea just feeling it outside of a stack. We were going to bale hay last year and bale wet hay and see if we could get one go up, but it was too wet. We couldn't get a tractor into the paddock just out there. So we were doing some opportunistic research. The first one here is these were bales of silage. When they got to 48 degrees, the CSU farm manager got a bit nervous because it was a strong wind blowing straight to that ripening barley crop. So we filled them full of water. And within 5 minutes, they were back down to 20 degrees. We then went out, and this is the sensor in the centre of the bale. After 12 hours, and we did it the second day as well because we found out they went back to 48 degrees. After 12 hours, they were increasing in temperature 5 degrees every 2 hours. And halfway to the edge, it was taking 4 hours to increase that 5 degrees, but it was doing it for the full 24-hour period. So it shows how rapidly we can get increases. We then contacted a farmer who baled hay for us early, so 2 days before it would normally have been baled. We baled it at 3 different pressures, what he normally would, a lot heavier and a lot lighter. In this graph, the grey line is the air temperature outside. And this is his low moisture, so normal time of baling. And you can see, apart from that little bit right at the start where we've had the initial reactions with the microbes and the chemistry going, it's basically followed the ambient temperature. That was when he'd normally bale it. When we baled it early, this is when we got to 65 degrees for a period. An increase of 45 degrees from the first reading. But the interesting bit was, yes, the heaviest bale, the thickest one, where the heat couldn't move out of the stack, was the hottest and stayed the hottest for a long period. But the lightest bale was the next hottest. And that was the same for all of our baling times. And you can see what he'd normally bale it at, even at high moisture, once it had settled down, was following that ambient temperature. So from this, what are our key findings? The commercial current sensor that we tested was suitable with some caveats. It's mobile phone linked. That's where Myriota were involved. We evaluated a new sensor, or it was the other commercial sensor. I didn't know it was available then. It showed promise, but it had some issues in it didn't have the spear to push it in. We gained a greater understanding of the influences on the process of combustion, but I will say what I normally say when I normally finish off, but I'll go on a bit. The more we've learnt, we realise the less we know, because it's so complex. 50 to 60 degrees seems to be a key temperature. We got it up there. It can cool from there. Sometimes one of the samples, that one with the bales at the different baling times, that recovered with no nutritional losses. We tested before and after, whereas the other one did. And ambient air temperature, we think, is playing a role in the bale temperature, in its either enabling loss or preventing loss of temperature. What I'd like to do is thank the two people that were working with me, Imtiaz Chowdhury and Joe Moore. IAG gave us the farmers, where we put a lot of the probes in, and the insurance information. Myriota, the cooperating farmers who are allowing us to drive in and out of their properties at any time, putting spikes in hay bales, and Food Agility CRC for funding. Thank you.